This video is entitled Further Investigation into Right Triangle Trig. And we talked yesterday, or sorry, in the last video, that sine of theta is equal to opposite over hypotenuse, and cosine of theta is equal to adjacent over hypotenuse, and tangent of theta is equal to opposite over adjacent. And then we quickly connect that to, well, that means it's equal to sine over cosine. Because opposite over hypotenuse divided by adjacent over hypotenuse would be opposite over adjacent. Okay? So knowing that, when you see sine of theta equals 3/5, there would be a temptation to think, oh, that's the opposite and the adjacent, or I'm sorry, that's opposite over hypotenuse. So that means that we must be thinking of a triangle where this is 3 and that's 5. But of course that's not necessarily true, because remember that sine, cosine, and tangent are ratios. And the one thing we remember about ratios, hopefully, is that you can reduce them. So these sides could have been 6 and 10, and sine of theta would still be 3/5. Or they could have been 9 and 15, and the sine of theta would still be 3/5. Okay, so you got to keep in mind that these are ratio. However, one thing to observe is, let's say that they were 3 and 5, and then we could use Pythagorean theorem to find out that that would make this 4. And let's compare one. So this is also sine of theta is equal to 3/5. But let's say this triangle is 6 and 10, which would make, if we use Pythagorean theorem, 10 squared would be 100, 100 minus 36 would be 64, square root of 64 is 8. So notice again, there's two different triangles, but the sine of the theta and the triangle are both 3/5, because 6 divided by 10 is 3/5, and 3 divided by 5 is 3/5. So notice, if we were to find the other trig functions for this, so cosine of theta, in this case, would be 4/5, and tangent of theta, in this case, would be 3/4, because we're doing this cosine would be adjacent over hypotenuse, and tangent would be opposite over adjacent. And notice if we do the same thing here, cosine of theta would be 8 over 10, which of course is the same thing as 4/5, and tangent of theta would be 6 over 8, which of course is the same thing as 3/4. So you can see, even though they're different triangles, if we can get the ratio of 1, we can find the other ratios without actually knowing the triangle. We never did. So if we knew that sine of theta is 3/5 and found these things, notice it could have came from this triangle or that triangle or any other triangle that's in the same ratio. So the key is to think ratio. So if we go down here, the whole point of this is to say, so if I know that sine of theta is equal to, say, 5 over 8, okay? I don't know that this comes from a triangle with sides 5 and 8, but I do know that there's a ratio there. So what I'm going to do is draw what I would call a reference triangle. So we got some angle here, and we're saying that we're not necessarily saying this is 5 and that's 8. We're just saying the ratio of that is 5 to 8, which is good enough for our purposes. So then we can use that to calculate this side, because 64 minus 25, let's see, 64 minus 25, that'd be 39. So this would be the square root of 39. So once I've drawn this reference triangle, so it's not necessarily the triangle, but it's a reference triangle that works, then I can come up with the other ones. So I know that cosine of theta is square root of 39 over 8. and tangent of theta has to be equal to 5 over 39, square root of 39. Okay? Now I'm feeling pretty good about myself, except for, once again, I don't know which quadrant I'm in. So this is a correct reference triangle, but if it's in the wrong quadrant, I might have some values off here as far as negative positives. Because remember, in the first quadrant, when sine's positive, cosine's also positive, which means tangent's also positive. When I'm in the second quadrant, sine is positive, but cosine is negative, and tangent therefore is negative. So just because if all we knew at the beginning was this, we don't know if that's coming from the first quadrant, second quadrant, third quadrant, or fourth quadrant. So we need some more information to actually be sure that this is right. If we were in the first quadrant, then those all would be right. If we were in the second quadrant, well, then we got a problem, because in the second quadrant, we know cosine's negative, which would make, but if we know we're in the second quadrant, then we could just make this negative, and that would also make tangent negative, because tangent is sine over cosine. Okay, so the key is if we just have one trig value and know what quadrant in, we can calculate all the other ones. So let's do another example. So let's say that I know that tangent of theta is, let's say, 2/5. And we're in the third quadrant. Okay, so first of all, I'm going to draw my reference triangle. Theta, and we got opposite over adjacent. So this guy is going to be, let's see, 25 plus 4 square rooted. So that would be the square root of 29, using Pythagorean theorem again. So now we'll just go ahead and say, okay, in the third quadrant, we know that tangent's positive, but both sine and cosine are negative. So that means I'm going to do sine of theta is equal to opposite over hypotenuse, so that would be negative 2 over the square root of 29. And cosine of theta is adjacent over hypotenuse, so that would be negative 5 over square root of 29. Again, the negatives come from the knowledge that we're in the third quadrant. Because in the third quadrant, I'm going to the left and down. So both the x and y coordinates would be negative, which means both sine and cosine would be negative. Okay, so give a couple more examples. Let's say that we have a drawing and we have a angle whose terminal side is right here, and we'll put a circle on there. This is a circle centered about the origin, but it's not necessarily a unit circle. And we're going to say that this point is negative 5,3. So that tells us clearly that is not a unit circle, because there's no way we could be over back 5 up 3 and have a radius of 1. So in fact, let's figure out the radiuses right now. Well, actually what we're going to do is draw a reference angle, right? A reference triangle. So in this reference triangle, we know that the length of this is 3, the length of that is 5, and the length of this is, let's see, 25 plus 9 is 34. So that's the square root of 34. Okay, here's some vacuuming in the background. Sorry about that if that's distracting you. So now we can just come up with the point. So what we're talking about here, this is our reference triangle. We're really talking about this angle here, theta. So if we do sine of theta, well, according to the reference triangle, that would have to be opposite over hypotenuse. So that would be 3 over the square root of 34. If I do cosine of theta, well, that's going to be negative because I'm going on the left, right? Or correct? So that would be negative 5 over the square root of 34. And then finally, tangent of theta. Well, that's opposite over adjacent, which would be 3 over 5, but it's also negative because we're in the second quadrant. Okay? So that's a little bit deeper look at, so knowing the trig ratios and right triangle, the relationship of right triangles, that gives you a little more power to figure things out. let's do one more example, I guess. So let's say that we know that cosine of theta is 2/3 and tangent of theta is less than 0. Okay? So let's draw a reference triangle, I mean. So here's my theta. That'd be 2 there and 3 there. And that would be 9 minus 4, which is 5, so that'd be the square root of 5. Ah, come on. Sorry, that's kind of hard to read there. Square root of 5. Okay, and since cosine's positive and tangent is negative, that's got to be in the 4th quadrant, right? Because that would be going over here, or going to the right and down, so that would make cosine positive, sine negative, which would make tangent negative. All right, so then let's go ahead and find the other trig values. So sine of theta would have to be negative rad 5 over 3, and tangent of theta would have to be negative 2 over rad 5. Okay, so using our understanding of right triangles and sine and cosine and tangent relationship, that's what this is talking about. So this will also help you with homework 2. There's a couple of problems in homework 2 where it explores this a little bit more. And this will also help you for homework 3.